Hi, I'm Rishan Riyal from Search Global. I'll be talking about edge computing today at NSBM for Technosphere. I'm glad I was invited over here, and I'm really honored for the organizing committee and the people around NSBM First community for doing something like this. I'm glad to share my knowledge related to edge computing today with you guys, and we'll be able to move forward with what I know about edge computing or sort of. So before moving ahead with edge computing, and the content that I'm going to talk today, I'll give some introduction to myself as well. Uh, Let me tell you my name again. I'm Rishan Riyal. I'm coming from Search Global. I'm working at Search Global as a software engineer over there. I've been in the industry for past couple of years now, almost 4 years now. I'm mainly working on Microsoft technologies and the Azure stack or sort of, and my forte lies on DevSecOps, application modernization, and system architecture related stuff. So let's dig into edge computing and see what's meant by edge computing and how we can evolve from edge computing and what are the applications that we can do from edge computing and in which kind of a level edge computing is in, or sort of. So when it comes to edge computing, what we should know about is actually, I have a slide over here, like you can clearly see. I'll try my best to explain what is meant by edge computing in a really layman terms or sort of. So as you guys might remember, when we host a web application into the cloud, that application will be hosted somewhere in the United States, East 1, East 2, or some sort of a location in Mumbai, or like where the cloud service providers servers are. That's the location that web application will be hosted. So imagine your application has been hosted in America or United States East 1, and there's a user for your application who is coming from Bangalore. When that user needs to request certain data from the web application, he has to access that one from that United States server. So which means there will be a huge response time or some sort of a latency for the Bangalore user compared to an American user. So to avoid this kind of a scenario, what web application developers did was actually, or the software engineers did was, they invented something called CDNs. Through CDNs, they were able to host static files into the servers all around the world. That's a decentralized system. And static files as like HTML, CSS, and those files were cached over there. And the users were able to retrieve them somewhat faster compared to the normal speeds or sort of. So to make those contents somewhat furthermore, what they did was actually they invented something new called serverless computing. When it comes to serverless computing, what we do is actually we host our dynamic content in the servers as well, or decentralized servers as well. In that case, the users will be able to access those content really faster compared to the early days. So when it comes to serverless computing, what really happened was there is something called cold start. So edge computing is nothing but serverless computing without any cold start. That's the very basic point of view what we can get from edge computing or sort of. So we'll move ahead with edge computing and see what kind of applications are there and what kind of architecture lies behind edge computing and how edge computing works or sort of. And we'll see how we can move, what kind of applications that can be created and all the stuff. So when it comes to edge computing, the core fundamental idea or the evolution behind edge computing lies on three main factors. The main factor relies on something called the storage. The storage is really important. So what they did was actually they tried to store the data that is relevant to the source of information to a nearby resource or to nearby application so that they would be able to access that content really faster. So that's the first step of doing things, remote data storage. So bringing remote data storage close to a source, that will make things easier for the source to access that information in a really fast manner. So then they did something called they wondered, why don't we move our computation as well? We can do computation rather than sending our data to be processed by by a remote location or by a centralized cloud somewhere else. Why don't we leverage from decentralized system itself? So what they did was actually they tried to implement the remote processing as well. So they implemented that thing and they were able to leverage that thing as well. So now they have both the remote storage and now they have both what you call uh, remote processing as well. Then the third stage of in the evolution was actually coupling. What they did by coupling was actually something like this. Let me say, like your remote storage is there now and your what do you call your remote processing is there now, and both the things are doing some sort of processing for the information that is coming from the source. So sort of now that information needs to be synced with the centralized database system, or so centralized cloud provider, or a public cloud, or whatever the cloud that we are using for the computation and the other stuff. So that's what coupling does. So sort of what we do is actually you couple the data that's being processed or that being stored in the remote storage along with the centralized clouds providers data. So that's how the evolution begin when it comes to edge computing. So let's move ahead with the edge devices. So sort of the very best example for an edge device would be the mobile phones that we are using nowadays in our hands. So sort of the edge devices, the mobile device is capable of storing data, and mobile device is capable of computing certain information. So when we don't have to send a request, or when we don't have to send a certain set of data to be processed in a long distance cloud server, rather than doing that one, we can do the same inside the mobile device, and we will be able to make our mobile device as a edge device itself. And the second one is a server in a data center, or it could be a traditional computer in a data center, or a normal server computer sort of. So we can use them to leverage the edge computing powers. So the very best example for edge computing would be the small devices, the Raspberry Pi or the Arduino boards or sort of, that we will be using for our computations and storage. They have got that capabilities and we can use them. And our drones can be used in agricultural factors. So sort of we can use drones to send information and like track our certain records and data related to the stuff. And the medical devices that we use in the industries nowadays will be really used in terms of edge computing, because rather than sending a data to the cloud service provider or to the centralized cloud, we can use them to, like, we can use the certain data that can be computed inside the application itself, or inside the medical device itself, will be what do you call computed, rather than sending that one back again to the cloud service provider. So those are the edge devices. So these are the edge devices that we are facing over here, or the edge devices that you can see over here, are regular day-to-day life devices. So now we need to wonder, how do we use this and leverage or enhance the power of edge computing in our day-to-day lives. So before moving forward, like, we should know the basic architecture behind the edge computing and how edge computing works after all. So that's one of the most important things when it comes to the edge computing, or sort of we need to know what's meant by the architecture and how the architecture relies, or sort of. So when it comes to edge computing, as you can see in in the slide that I have shared, there is something called the central processing storage, or sort of, that's the central cloud. That's where the everything happens. That's where our main things and everything happens, or sort of. So when it comes to the centralized processing and the centralized storage, that's our main cloud service provider. Let it be Azure, let it be AWS, let it be GCP. That's how, or it may be an on-prem as well. Like, we won't be using on-prem after all, but like we can consider, or it can be a local server somewhere, stored somewhere in a location, or sort of. Then we have our edge devices. We have the edge devices, or the subcomponents to be per se. Like, there is something called the data storage, and there will be, if you are using any, like, what do you call, knowledge processing related stuff, then there is something called knowledge processing, and there is the computing or the processing related stuff, and the management and secure related stuff will be there. So that's known as the edge processing. So this will be done inside the edge devices itself, and through the edge devices themselves, they will be transferred into the, what do you call, centralized processing, or the centralized storage, or the cloud storage when needed. So they will be kept in the sync. So overall, these both, the central processing storage, or the central cloud, and these edge computing will be considered as the, or the edge processing will be considered as the overall edge computing, or sort of. So when it comes to edge computing, uh, like, how do we say that? Yeah, let's move ahead and we'll see an example and go through the things. So sort of, before moving ahead with edge computing, there are certain prerequisites that you need to know about. Mainly, you should know about what's meant by cloud computing, and how cloud computing works, and what are the services given by the cloud computing, or sort of. Then you need to know the basic fundamental ideas behind data and information, and how data will be processed over time to an information, or sort of. Then you need to know certain things about security concepts as well. The security is one of the major concerns when it comes to the edge computing, or sort of, so you need to know them. So the other one is actually governance concept. Let's not bother about governance concept right at the moment. And there is something called IT operation, the fundamental IT operation, how IT operates all along the industry, or sort of those concepts. So the basic roles and responsibilities when it comes to the IT operation. Then, so let's talk about the very core concept that relies over here. What is edge computing, right? So it's an architectural uh, design, or sort of like in an architectural manner, if we say, that's a network architecture for computing and storage. That's a decentralized architecture with a centralized system itself as well for computing and storage. That's the powerful that's the most important thing about edge computing. So when it comes to edge computing, we have both the decentralized architecture, or we have both decentralized storage and computing, plus we have a centralized cloud storage as well, cloud storage and cloud processing as well. So let's go forward and let's see what are the things as well. So there are edge devices. When it comes to an edge device should be able to do these three types of things. One is known as compute, the other one is storage, the other one is networking, right? The compute is usually known as processing. An edge device should be able to process data whenever requested or whenever needed. Rather than sending data back again to the cloud, the edge device should be able to do the processing, or edge device should be able to do the computation. And the storage is one of the key concerns when it comes to the edge devices. Edge devices should be able to store the data whenever it's needed, rather than sending back again. So the networking can be done by usual 5G cellular networks or 4G cellular networks. The networking is important to communicate, do the intercommunication transactions between the edge devices itself and between the cloud as well. So now, so for an example, we can take an edge device. I have taken an example over here, that's Raspberry Pi or sort of. So Raspberry Pi is one of the cheapest computers that you can buy in the market. It's all around $50 or something like that. And we can leverage Raspberry Pi into an edge computing device. If we use that one in a proper manner, or sort of, or if we enhance that one in a proper manner, or sort of. So Raspberry Pi has all these three things. Raspberry Pi has the storage, Raspberry Pi has the CPU, and Raspberry Pi has the networking as well. So when it comes to Raspberry Pi storage, networking, and the CPU, we know like Raspberry Pi doesn't have a huge amount of storage or huge amount of CPU power or huge amount of networking power, but it has a small amount of power, small amount of storage. So we can use that one to leverage into edge computing. So that's the idea. And we can run any kind of an operating system as our own. So sort of we can implement Linux, or we can do any kind of an operating system. So we can change the virtual operating systems as well. That's another feature that edge devices gives us. So now, so here is the basic edge architecture, or the edge architecture that we are going to look into, sort of. So when it comes to edge architecture, there are three layers over here. The first layer will be considered as the data source layer, or the sensors where the data will be sent, or sort of, for the source of information. That's the place where the data will be transmitted. And there will be something called edge computing, edge computers, or sort of, those are the edge devices that we will be using. And there will be our cloud service, or the central cloud. So when it comes to the sensors and the data input, that will be coming from, most of the time, sensors, the whatever the sensors that we are using in our systems, or sort of, that they will be considered as the sensors, or sort of. From them we'll be picking up data, and we'll be sending them through what? We'll be sending them through an edge computer. An edge computer would have three different things. One, as we discussed earlier on, there will be storage, there will be computation, and there will be the knowledge processing, or the machine learning stuff. So if we like, when it comes to storage also, like you can clearly see, these are like the edge computers will be like nodes, or sort of. So they are interconnected together. So which means they are in between the edge devices itself, there relies a network, or sort of. So the edge devices will be able to communicate with themselves. Imagine a scenario where the whole central server is down, or the central cloud is down, or the down part of this one, the third box over here would be down, or the third layer is down. It won't be a big deal, because the edge devices have their own kind of a network, so they will be able to continue the transaction, so continue the whatever they are doing inside the system, even the central base system is down, or sort of. So yeah, so when it comes to the cloud-based provider, the cloud-based provider will have like excuse, the cloud-based provider will have some there is an OLTP, like online transaction processing systems would be there. If there are any analytical transactions that are happening, those things will be done as well. So external device data, if there are any external device data are coming from any external things, if anything is available, so those things will be there as well. So when it comes to the central cloud-based computers, so those will rely on the lower part of our system, or sort of. So when it comes to, say for an example, so when it comes to the, like over here, I have mentioned already, the lightweight edge processing will be done inside the edge computers, and heavyweight processing will be done inside the cloud service providers. So when it comes to the cloud system, or sort of, or the central cloud computer. So when it comes to what you call the edge computers, like imagine an example like this. Say for an example, we are using an edge computer inside, like we have an edge system inside a jet engine, or sort of, imagine we have a jet engine, and like and like the sensors are giving, like imagine we have a jet engine, and inside that jet engine, if you are using an edge system, or sort of, if you have an edge computer system, right, imagine, and like we are giving some input from the sensors from the fuel tank or something like that. Rather than sending all the data back again to the central cloud and getting back the responses, the edge computers can predict the data, because they have already the machine learning components and knowledge processing components. What they can do is actually, based on the inputs that were given from the sensors, they can predict what needs to be done and what kind of things needs to be done from the fuel tank itself, and they can process that shit and they can send them through. So that kind of an architecture relies over here. So whatever light processing that needs to be done really quickly will be done inside the edge computers, and whatever that needs to be done in a heavy manner will be done inside the cloud service providers or the cloud computers. So when it comes to edge computing, this is the main factor. This is how the edge computing works. After all, this is the overall architecture of edge computing. And like uh, yeah, let's move ahead with the components of edge computing. When it comes to components of edge computing, the main components would be the sensors. Sensors are really required. These sensors will be considered as the source of information. So when it comes to source of information, they will be carrying off, like they will be collecting data from all around the system, or sort of they'll be taking up like the inputs related to temperature, maybe humidity, maybe location, like lot of information. Like say for an example, if you take a car, or sort of the inside the cars, there are a lot of sensors, and those sensors would be able to detect any anomalies, or any accident detection can be done, or like any reverse detection can be done. So sensors are really important. Sensors relies on the first layer of the application or the system, or sort of, and sensors will be considered as one of the key components of an edge computer system. So then the edge computer itself is there. So edge computer will have a processor. The edge computer would obviously have a processor. There will be a solid storage device. There will be Wi-Fi. It will have its own network interfaces, and it will have its own operating system along with some machine learning or the knowledge processing, because knowledge processing will give the leverage over much other systems, or sort of, rather than normal a decentralized system. So then we'll move ahead with the third layer of the component, that's called the cloud-based central computer. So this is the cloud computer. This is the main computer that we will be using. This is our main server. So the cloud computer will have virtual databases. So what's meant by virtual databases over here is actually, rather than making changes to the physical database directly, what we can do is actually we can do some changes to the virtual database, and we can make our changes on virtual database. And later on, if those changes that needs to be done in permanent manner, we can do them in a physical database. So virtual databases are really good when it comes to, like, when we don't know how physical database exists, or sort of, or when we don't know how physical database works, or sort of, that's the idea. So so when it comes to a cloud computer, it will have its own virtual processor, it will have its own mass storage, and there will be network interfaces, and there will be a virtual operating system as well. So that's the idea of cloud-based central computer. So all these three layers together work together to perform to create a one whole system known as edge computer system. So I hope that gives you a fundamental idea of what's happening over here. Next, we'll move ahead with the edge computing architecture, and we'll see how it goes, or sort of. Now we'll talk about edge computing architecture, or how edge computing architecture works, or sort of. So what's the architecture behind the edge computers? So there are four main components. The first one being the networking, or sort of. So the networking is really important to communicate between the cloud service provider, the cloud computer, the central cloud computer, and between the edge devices itself. So networking is one of the core components for a edge computer itself. And there should be the computation, of course, or the processing power for the computer. Without the processing, the computer won't be a useful thing. So, and there will be the storage. Storage will be a very small, or a tiny storage would be there, or a very smaller one would be there. It will be created using an SSD or something like that. Then there will be the management itself within the edge computer, so that it can manage itself, or sort of. So this is how the edge computing architecture works, or this is the core four concepts behind an edge computer. So if you are building an edge computer, or if you are building a device, these four components should be there. Without these four components, it's not a fully fledged edge computer itself. Then we'll move forward with the certain dogmas that are available in the industry regarding edge computing and the cloud computing. It's not about edge computing, like we need to bridge the gap between cloud computing and the edge computing after all. So we need to find a link between these two. It's not about edge versus cloud, rather it's all about edge and the cloud or sort of. So these are not mutually not exclusive. Rather, these things work together. The central use of edge computing relies on cloud computing. Without a cloud computing resource, there is no edge computing after all. Or without a public cloud, you won't have the leverage of edge computing after all. So that's the idea behind the linking edge computing and the cloud computing all together. So when it comes to cloud computing also, we know that there are certain processing powers, there are certain storage things that we will be storing inside the cloud storage, and we will be moving our parts of certain application or the pieces of our application into the edge computers itself, and the edge computers will be able to process them. Meanwhile, the central compute or the central cloud computer will be doing some other task. So yeah, so the point is actually you can't have an edge computer without a cloud computing device, or without a centralized cloud device, or without a public cloud. So when it comes to when it comes to the cloud compute also, when it comes to the central cloud computer, there is one of the major factors that we should know about. The cloud computing will always be responsible for the centralized data storage and the centralized commands. So without the commands of cloud storage, the edge computers won't do any task. It's on or sort of. So there are certain specific things that a edge computer will be able to do or sort of, but the centralized things will be done by the central cloud itself. So there are a couple of edge services that are available in the cloud market right at the moment. So there is something called microcloud. So an example for the when it comes to AWS, they have a service called AWS Outpost, and Azure have a service called Azure Stack or sort of. So these are known as microclouds. Microcloud is nothing but a private cloud inside an enterprise data system or enterprise data center. So that has been leveraged on edge computing. So that's the kind of an idea behind Azure Stack and AWS Outpost. So when it comes to there is another thing called edge system management as well, that is called AWS IoT site-wise edge or sort of. So what we do over here is actually we will be controlling the IoT devices through the power of edge computing. So let's see the differences between both Azure Stack and Azure. So when it comes to Azure, Azure is something like in Azure, if I hope you all might have have seen Azure sort of. Azure has its own capabilities. So when it comes to Azure, we have got the Azure Resource Manager and stuff. Azure is an infrastructure as a service or a platform as a service, and it has its own cloud infrastructure. So when it comes to in terms of Azure Stack, what we really do is actually Azure Stack is created based upon the based upon the cloud inspired infrastructure rather than cloud infrastructure itself. So it's like you have a huge cloud, and inside that huge cloud you have a small cloud of your own based on your own hardware system. So based on your own integrated systems or sort of. Meanwhile, the Azure will be running on its own Azure hardware components. Meanwhile, the Azure Stack will be running on our own integrated systems. So we can use Azure Stack to develop applications and do certain stuff that we need to do when it comes to the edge computing itself. So how do we do the development and how do we continue regarding the deployment? So how we move forward from development to deployment when it comes to edge computing? So it relies actually on the public cloud itself. What we can do is actually using the cloud infrastructures that are given, or the public cloud that we have, let it be GCP or AWS or Azure. We design our system, we design the artifacts and everything. Then we build the system, we code the system, and then we build the system. Then we define our data, what data will be transferred, or we define our schemas, we define our databases and everything. Then we test the system against the data that we push to the system or sort of. Then what we can do is actually we can choose to deploy the system into the central cloud itself, or else we can deploy the system into the edge service itself or the edge device itself. Or else we can choose to deploy that one to both the systems itself, or both the systems itself, both the cloud system and the edge system itself. So that depends. So when it comes to the cloud system itself, what we have is actually when we have a cloud-based system or sort of we will get the application development life cycle of a cloud-based system itself. So we can use the same life cycle to build a system for the edge computers as well. So which means we will have the leverage of DevOps for the edge computing as well. So we have the power of, we have the capabilities of cloud computing. So which means we will have the leverage of DevOps that we get from the cloud computing as well. So which means we'll be able to use in IAC or sort of or infrastructure as code. We'll be able to have serverless functions. We'll be able to have microservices. We'll be able to do logging and monitoring, and there will be CI/CD as well. So it's all about like the fundamental idea behind edge computing or fundamental idea behind the developments for edge computing relies behind something called like you develop something for the cloud, you will be able to develop the same shit for the same thing for the edge computing as well. That's the fundamental idea. So what's next? So after this one, where do we go? Like what's the future behind edge computing? So what relies in the future for edge computing is actually something like microbotics can be used, the micro robots that we inject into our bodies itself. So we can use microbotics into an edge computing level, and we can use them to transfer data in between those devices, and rather than sending them to a central node and doing the transactions. And we can use edge computing, or we can leverage the power of edge computing in the carbon emissions, or to reduce the carbon emissions when it comes to the climate change. What we can do is actually we can use the vehicles, and inside the vehicles we can keep a sensors, and we can decide how much carbon should be emitted based on the current situation of the environment or sort of. And we can have the automated portability when it comes to devices. So then, the conclusion of what we discussed today when it comes to edge computing, what we need to do, and where do we move forward when it comes to edge computing or sort of. So mainly, look at public cloud services. When it comes to Azure, they have the Azure stack. When it comes to what do you call AWS, they have the Outpost. So look into those services. Those services are demo versions are available. Try to host them on a cloud application. Sorry, try to host them on a edge device or sort of, and you will be able to good to go. Then experiment with the devices or sort of. You can buy yourself a Raspberry Pi computer, and if you are really a techie person, what you can do is actually you can install your operating system, and you can create your own version of an application into that one, and you can see how edge computing works, and try to build some applications. It will be good to go with what do you call edge computing. So I hope whatever we discussed today, you got a fundamental idea of what's meant by edge computing and how edge computing works on the current modern world. And I hope you got an understanding behind what's meant by serverless, and how cloud computing differs, how serverless and cloud computing differs from both edge computing and the other spectrum. So there's something called fog computing as well. Do your researches on fog computing and see how fog computing changes from what you call cloud computing itself, and how it moves in the spectrum of technology. So sort of. So thank you guys. I once again I thank the committee of First Community for having me over here. I'm really honored to be a part of this Technosphere program. Thank you, and wish you everybody a good luck.